Assalamu alaikum. In this video, I will be explaining about OSI model, and at the end of the video, I will compare it with TCP/IP suite. So OSI stands for Open Systems Interconnection, and it is a reference model which is used when data communication occurs on networks. It is a layered architecture and it has 7 layers. The purpose of this model is to explain network communication among hosts among different computers networking devices which occur on either local area network or wide area network. It further shows communication of different protocols with one another, like protocols of one layer with another. So it further categorizes protocol for their respective layers. It means that the protocols are categorized in layered architecture. So it is easier to understand a protocol because one protocol does not interfere with another layer. So a protocol only works for the layer for which it has been designed. So in OSI, we have 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So the process of going top to the bottom in the stack is referred to as encapsulation, whereas going upward in the stack is referred to as decapsulation. In this video, I will be giving a introduction to each layer and its functionalities, and in future videos, I will be explaining in details about each layer and its functionalities. So, application layer deals with network aware application. Let's say we have some sort of data that we want to send to another computer. Here we have data that we want to send to another computer. So what each layer does, it adds a header. Every layer adds a header to the data, and each header contains control information inside it. Only layer 2 adds a trailer, and no header is added at application layer. Okay, so after application layer inserts its header, this this thing here is referred to as protocol data unit, or more precisely application layers protocol data unit. Similarly, presentation layer protocol data unit, and so on. Right? The protocol data unit from layer 4 to layer 1 has a special name. At layer 4, PDU is referred to as segment. The PDU at network layer is referred to as packet. PDU at data link layer is referred to as frame, and PDU at physical layer is called as bits. The trailer here is actually used for frame check sequence, more like data correction, and this shall be discussed in details in future videos. This layered architecture is also important for detecting errors in day-to-day life. So let's say if a error has occurred in a running network, so what we would do is we would start detecting the error from layer 1. We would first check if the wire is faulty, or the connector is faulty, or the network card is faulty, or there is an IP conflict, and so on. So this OSI layer is also comes in handy when we are trying to detect faults in our running system, in our running network. So let's begin with physical layer. So in physical layer, the PDU, as already discussed, is bits. The device that we use at physical layer is called as hub. So what physical layer does is it converts bits to signal elements. So let me explain what it means. So let's say we have a stream of bits. So what would physical layer do in simpler terms? It would convert ones and zeros to signals. Okay, there are many techniques to convert the bits into signals, like return to zero, non-return to zero, Manchester, differential Manchester, and so on. So if you want to go into details, you can study this yourself, but in simpler terms, you just need to understand that physical layer, the function of physical layer is to convert bits to signal element so that they can be transferred through wire. Okay, so these signal elements can be like electrical current if you are using Ethernet, or it can be optical fiber like light pulses in optical fiber. So the concepts that come into physical layer are analog versus digital encoding, baseband versus broadband, which uses the concept of modulation, topologies, which means arrangement of network, and bit synchronization. This simply means that the bits needs to be synchronized from sender to receiver. So let's move towards data link layer. So the measurement unit or protocol data unit in data link layer is called as frames. We have source and destination address in frames. So the devices which operate at data link layer are called as NIC, switch, bridge, and access point. The basic features of data link layer are uh, error control and flow control. Error control ensures error-free transmission through physical layer, which is below this layer, by the techniques called as parity check and CRC check. Okay, the flow controls also have certain protocols which are used in data link layer. Furthermore, we have MAC addressing, which is also called as physical addressing. The reason MAC address is called as physical address in data link layer is because MAC address is burned into ROM of NIC, and this MAC address cannot be changed because it is actually burned into ROM. However, the MAC hackers actually change the MAC address, but if we talk about normal terms, MAC address of a device never changes because it is hard coded onto the ROM. However, through software, certain software techniques called as MAC spoofing, this can be changed. So keep this thing in your mind. So if you just open up your command prompt and insert this command, you would see something like this, and the physical address that would appear in your command prompt would be your device MAC address. Now let's move towards network layer. So the PDU at network layer is called as packets, and just like before, it also has source and destination address within a packet. The devices which operate at layer 3 are called router and layer 3 switch. So the data link layer uses physical addressing, so layer 3 uses logical addressing instead of physical addressing. Logical address means that these are available within operating system, and the types of logical addresses are IPv4 and IPv6. So logical address, just like I said, is stored in operating system. Operating system may be your like Android, your Windows, Mac, Linux, or even switches operating system in your switch and routers. Of logical addresses are always stored in these sorts of operating system. So what we have established so far, let's discuss. We have established so far that a computer has at least typically two addresses, a physical address and a logical address. Okay, so networking, if I describe it in a nutshell, actually goes around in these two addresses. We need to make sure that these two addresses work along together, and we will see in future lectures how we actually make sure of it. So actually, if I explain, networking is also called as routing and switching, as you must have heard the name of certain certifications, CCNA, SCIA, routing and switching. So routing is actually done at layer 3 and switching is actually done at layer 2. So in a nutshell, if I define what is networking, so the networking is actually done at layer 2 and layer 3. So these are the two layers that we will be focusing in this series, and we will touch other layers too, but what we will do, we will primarily focus on these two layers in our in this series of tutorials. Now let's move towards transport layer. So the measurement unit or protocol data unit at transport layer is called as segments. What it means is that segments means partitions. So what it does, it takes the data from upper layers and it partitions them into units, or we may call them as data units. Just like before, like we discussed in MAC address and IP addresses, this layer also has port addresses, and it contains, just like before, source and destination address. Okay, so no need to be confused about it. So about this point, all other layers above this one are units in terms of simple data or messages. I have explained it in previously that the upper layers 5, 6, and 7 there is no name for their PDU, so we just refer to them as session PDU, presentation PDU, and application PDU. The only naming conventions of the PDUs are from layer 1 to layer 4 that we have discussed. So what we have discussed so far is layer 1 had bits, okay, layer 2 had frames, layer 3 has IP, and now layer 4 has what? Port addresses. Okay, so these four are the naming conventions of PDUs. Layer 5, layer 6, and layer 7 does PDU has no name. So segments, what layer 4 does is segments the whole data into smaller data units, and each data unit has a source and destination port number. Okay, so keep it in mind. Source and destination port numbers. Other than these port numbers, it also has a sequence number. Okay, I will explain a bit about sequence number. Just wait a second. So the protocols used at data at transport layer are TCP and UDP. Just like layer 2, transport layer also has error control and flow control. So let's come back to sequence number. I will explain sequence number with conjunction of error control. Okay, let's say we have source and destination. Source sends a segment to destination. Let's say destination has received it, so destination would tell source with sequence number, like it has sent sequence number 1. So destination would tell source that he has received the segment, so now please send the next one. So the source will send a sequence with uh, the segment with sequence number 2. If acknowledgement has not been received by source, so what source would do? Source would send the data again. This would actually ensure reliability of data. This mechanism is actually of TCP. I just explained briefly in very short about the sequence number. We shall discuss about TCP and UDP in future details. For now, you just need to understand that TCP is connection oriented and UDP is connectionless. TCP ensures that data is actually sent to the destination. It makes sure of it. However, UDP just sends the data. So there are pros and cons of it. So in TCP, we compromise time over reliability, and in UDP we compromise reliability over time. We just do not want to make sure whether the data is received by at the destination or not. We just want the data to be reached at destination as soon as possible. The application of UDP is generally like video calling and things like that. So you must be confused about why do we have error control and flow control at layer 2 as well as layer 4. Why not just one? So there are certain discussions on forums that you may see and study about it. It is actually a big topic, but I will explain just one example. Let's say we have two computers. Okay, we have two computers here. Don't mind my trying. And let's say we have a switch, two switches here, and a router here. Okay, and these are connected with one another. Let's say PC1 sends wants to send the data to PC2, and we are using connection oriented protocol, TCP protocol. Okay, so what let's say that an error occurs at certain this point, right? So what switch would do? Switch actually ensures error free transmission at physical layer. Okay, so let's say an error occurs here, and it has detected the error and corrected the error through certain techniques, which are through certain techniques that you do not need to go into the details. So what would happen if an error occurs in some higher layer, like layer 5, let's say? So for that purpose, uh, this error and flow control needs to be ensured by AND PCs at two destinations. This is just one of the reasons that I studied from forums to explain this slide. However, there are more than like 3 to 4 reasons for that. So if I might actually create another video for it. So for now, just let's move towards the next topic. Before going towards session layer, let's understand the difference between socket and session. So Google's definition of socket and session is simple. Socket means a natural or artificial hollow in which something fits or in which something revolves. Like we insert a wire into a socket, something like that. Okay, and session means a period devoted to a particular activity. So in terms of networking, what socket is, we have studied 3 types of addressing. So when we combine IP with port, then this thing is referred to as socket. Let's say we have IP 192.168.1.1, okay, and we combine it with port number 80, then this whole thing is referred to as a socket, and this is also a endpoint of a host. Okay, it is an endpoint over which two programs communicate. If you are from a programming background a bit, you know how APIs work. You need to give some endpoint to it. So this is the starting of the endpoint. Okay, so this is a socket. IP and port makes up a socket. Now, what is session? Session means a temporary and interactive information interchange between two hosts. So let's understand these two things with a example. Let's understand the scenario first. Let's say this is our computer. We have this IP address, and this is our port number. Okay. Do not be confused about how this port number came. So you just need to understand that when your computer wants to communicate with some other computer on internet, so it gives itself a random port number. Okay, so this is how this random port number came. So let's say this is your PC, and you want to communicate with a web server. Okay, so let's say this server has virtualization. Do not be confused by virtualization. Just let's say it has two virtual machines running on it. Okay, each virtual machine has its own set of IP address, VM1. Now do not be confused about what virtual machines are. Just understand that a machine can be broken up into multiple machines, and these multiple machines are called as virtual machines that you virtually use. You must have used it, or if you have not used it previously, just assume that there are two machines virtually running on the server. Okay, the IP of one machine is 1.1, and IP of second machine is 192.168.2.1. Now let's say you want to communicate with a web server which is on virtual machine 1. So how would you connect? There could be like hundreds of virtual machines running on the server. So what do you need? You need an IP address, right? But not just IP address, you also need a port number. Now why would you need a port number? Because a server would not necessarily be running just a web server. It might be having other services as well, like email services and other services. So you want to make sure that you want to communicate with a certain machine and a certain service, right? So that is why this endpoint is needed. So you have now pointed out that you want to use a virtual machine 1 and you want to use its web server. Okay, so you have now uniquely identified what you actually want to use. So this is how socket comes in handy. That socket comes in handy in helping you where you actually want to connect yourself. Okay, so now you have proper end connectivity. Now what is session? Now let's say you have sent a request to a server on 192.168.1.1 colon 80 and server asks you to authenticate yourself. Authentication means it will ask you to provide certain username and password. Now let's say you have provided username and password to the server. Okay, you have provided username and password. Now a session will open up. What is session? As we have discussed, it is established at a certain point. Now the session has been established. Now a session has been established, and let's say this server is of Facebook. Now you have logged into your account. Each and every person will have their own session. Okay, so they are using their own profile. They will only be able to access their own messages, not someone else's messages. So this is where session comes in handy. As long as the session has been established, you will be able to send messages to your own friends, not someone else's friends. Okay, so how will the session will be like terminated or torn down? When you log out from the Facebook. Okay, when you log out, the session will be terminated, right? So this is how session and sockets actually come into play. Now let's see a little extension to this example. Let's say you also want to use their email service. Okay, like Facebook has launched certain email service and you want to use their email. Just assume. Okay, so what you would do? Now you would do the same thing. You would now you would use another port. Let's say you would use port number 25 to connect to it. Please remember that you already have a session going on with Facebook on their web server. Now you just want to use their email service as well, so you would send another request, and then depending on their policy, they would ask you to authenticate, obviously giving your username and password, and you would authenticate yourself. Now another session would be established. See, with one server you have two sessions established, and in those two sessions a different kind of information is being processed, is being communicated from one party to another party. So make sure that you have actually cleared the concept of this socket and session, and do not get confused when we get into some complex topics ahead in our future lectures. Now let's discuss about session layer. So session layer establishes sessions, maintains it, and then terminates the session. Okay. So the protocols used at session layer, NetBIOS, and others. You just don't need to get in details about it right now. Okay. So if you just open up your command prompt and insert this command, you will see a list of connections. Some of them would be established, and some of them would have a different status. So what you need to do right now is just restart your computer and log into the Facebook. You would see that a session has been established. You can see that this is a source, and a random source number has been generated by your PC, and the protocol used by it is TCP, and the destination is actually using 443. 443 is nothing but a secure version of HTTP, like HTTPS. HTTP use port number 80. Okay, so just test it yourself. Log into the Facebook, and then you will see that your connection has been established, and then when you log out and check the same entry, you would see a different status. So just try it out yourself, so that it you may remember it for longer period of time. Now let's discuss about presentation layer. So what does presentation layer do? These are the three main functions of presentation layer. It takes data from application layer and and format it into something that actually can be transferred into the network, or it receives data from session layer and gives data to the destination application by formatting it into the pattern which can actually be understood by it. So let's say we have application layer here, presentation layer here, and session layer here. So what it does, it formats data. Let's say there's a certain application Firefox which understands certain sort of data, so it would convert into something like binary and give it to session layer. Or if data is received from session layer, it would convert into something that would be understood by Firefox. Other functions performed by it, let's say it has received data from application layer. Okay, so what it would do, it would compress it. Okay, it would compress it. The compression, it might compress it depending upon the configuration. So what compression comes in handy when there's like gigabytes of data and you want to compress and send the file to someone else. Or it might encrypt the data for security reasons, so that it can be decrypted at user destination, so anybody in the way would not be able to read what actually is inside the data, right? So these are the three main functions: it translates the data, compresses the data, and encrypts the data. Finally, we have application layer. It is responsible for the protocols used by the network application to establish communication. Examples are like Chrome, Outlook, Zoom. Please note that not every application works at application layer. Only those applications which are network aware, like Firefox and MS Office, in which you can actually log in. The applications which actually work at internet are application layer applications. So the protocols at this layer are HTTP, secure version of HTTP, Telnet, secure version of Telnet, FTP, SFTP, and etc. With the help of these protocols, services are provided to network application. Let's say you want to use the website, you would use HTTP, right? So these protocols actually help in using the services available at application layer. So we have actually discussed from layer 1 to layer 7 up till now. Now let's discuss a bit about encapsulation and decapsulation that we actually started from our slide. So let's say we have two computers here. Okay, so PC1 wants to send a file to PC2 through a service called as FTP. It uses a port number 21. Okay, so at layer 7, FTP would actually the layer 7 would application layer is going to insert its own header. Layer 6 is going to insert its own header, and encapsulation process would begin. So in real life scenario, if I want to explain to you how it actually happens, is that let's say you have data, simple data like a file dot jpeg. So what application layer does is that it puts it inside a box, okay, and gives it a label called as application PDU, by using its own control information and the certain things that it inserts itself. So when it goes down to it, presentation layer is going to put the APDU inside another box, and then it is going to call it PPDU. Then session layer would do the same thing and call it SPDU. Then transport layer is going to segment the whole data and call each data unit as segment. Then layer 3, what would layer 3 call it? IP. And then layer 2 is going to put it into another box and would call it frame. Please make sure that it also puts a trailer here for error checking, etc. So when this box comes at physical layer is going to actually convert it into signal units and then transfer it through a Ethernet wire or wirelessly or fiber optics. I have actually showed here bits, but what it actually happens here, through wire, the signal like this is actually sent. So when it is actually received here, what would the physical layer do? This physical layer is going to converts signal element and bits element into frame. Now it has this huge humongous box. Okay, so it is now going to extract IP packet out of it. It is going to check source and destination frame here. Okay, it is going to first check source and destination frame. If it verifies that the destination is its own address, then it is going to open a IP packet. Otherwise it would reject it because it does not need a frame which is not actually destined for itself. Now it is going to check an IP packet. So in IP packet it is also going to, like, there are certain complex things in frame, IP and segment. I'm just focusing on source and destination. So in IP packet it is also going to check source and destination IP. If the destination IP matches with itself, then it is going to open this box. Now it is going to also check uh, it is also going to check the destination port number, and then it will open this box, and then from presentation box it is going to decompress or decrypt the data and then send it to the finally application layer, like this application is using FileZilla or any other software to receive the file. And after you have opened certain software, the receiver will have this file. If you have not understood this process of how the data is actually sent, so do not be confused. I will be actually explaining physical layer, data layer and network layer obviously in very detail in future lectures. So just make sure that you have understood the essence of OSI layer, how and why the OSI layer is necessary. So let's say an error has occurred in your network. So how would you troubleshoot it? You would actually check a wire, right? Whether the wire is cut from somewhere. So the wire is all right from everywhere. Then you would check the connector at physical layer, whether the RJ45 connector used is okay or the connector is faulty. If the connector is also okay, you have checked it the connector, then you might wonder whether the network card is faulty or not. Then you would check the network card, or you would check the MAC address, whether the MAC address is conflicting or a hacker is attacking your MAC address, etc. MAC is putting other hacking techniques. Then if there's no error found, you would check IP config, whether the same IP has configured on two ends, or there are like STP is not configured, like STP is at DataLink layer. Like there could be like many problems, but the problems become easier because we have hierarchical model at OSI. So this is one of the best way to actually detect the error and to design the protocol. Let's say you want to work on your research and you just want to develop a protocol for certain layer. So you just need to focus on that layer only, okay, for standards, for the standard purpose. This is how OSI and TCP IP suite comes in handy. So this is the comparison between OSI and TCP IP suite. So on left side we have OSI and here we have TCP IP suite. So just don't be confused what we have studied for so far. In TCP IP suite, these three layers have been combined into one. These two are same, these two are same, and these two have been combined into one. That's it. You do not need to be confused about TCP IP suite since you have studied OSI layer in detail. So this was the presentation. I hope you must have understood something out of it. Thank you.